So, good afternoon, and welcome to my presentation about the Smart Component Library and especially some of the refactoring features that we have in the framework. I'm Mike Fechner. I'm running Consultingwerk, but I'm also involved in our customer projects, typically in the role of an architect for modernization-related questions. And within Consultingwerk, I also work as a product manager and architect of the Smart Component Library. And very often also as a developer. A day where I just can spend with code, it's like a definition of a good day for me. Using Progress since version 5, so I've been involved in quite a few modernization initiatives since then. Yeah, we at Consultingwerk, we support companies that develop applications in OpenEdge, maintain OpenEdge applications. We focus on OpenEdge, but also on other technologies that, make some sense to be used together with OpenEdge, various front-end technologies like .NET, web frameworks like Angular. Our main office is in Cologne in Germany. Our team of 17 people is spread, through various European countries with colleagues in England, in the Netherlands, Romania, with one colleague here in Czech Republic. He doesn't speak a lot of Czech because he's also an Englishman who he moved here for his wife, but and we have one colleague in the United States. Our customers typically all over Europe and North America. A few more distant customers in Australia and in South Africa and Namibia. Yeah, and the way we support our customers is through developer tools like the Smart Component Library developer framework, but also consulting services or developer services. Typically as part of a modernization project that the customer does. So, what I want to do is I want to give you a brief overview of the framework, few aspects at the back end and the front end, and then some specific aspects of how we can use existing ABL code and analyze it in a semi-automated fashion to achieve a semi-automated migration. I'm never going to promise anyone that you load a whole OpenEdge application that was grown over 30 plus years. We push one button and half an hour later we have a new application. And I believe that's hard to achieve. I'm not saying it's impossible. It's just a question of time and money to solve that problem, probably. The other question is whether that would be achievable, something you want to achieve. Because typically when we start with customers talking about modernization, nobody tells us, oh, we have the best architected character application and we would like to keep everything, just put a web interface on top. Typically we have things like, oh, the code is aged and nobody understands the code and we don't want to change anything because we always are afraid that it breaks stuff. And the developers that are responsible for all that mess are soon to be retiring and we need to make this code base attractive for young developers and all this stuff. And if we would just do a source-to-source conversion, we wouldn't make any of that better. If you want to have a really nice application, you need to put in some efforts in designing it nicer and avoiding some of those mistakes and avoiding redundancy and making it testable and stuff like that. So, with the Smart Component Library, we provide a full-stack modernization framework. Full-stack typically is referred to as we have back-end and front-end components. Our front ends are an Angular web application and an OpenEdge GUI for .NET desktop client. We also have components for mobile applications. We don't use them that much because our customers don't write that many mobile applications. It's just not the market space we're in. And the backend is typically an OpenEdge pathway backend. So it is definitely an OpenEdge backend. And now with the end of 11.7, we all know now 6 months to go for 11.7, then it will be, it will still be running, but definitely not advised to be running it anymore. So pathway is the future for the backend. And when it comes to front ends, I truly believe that whatever front end technology we know now, nobody can promise you if it's still up to date in 2-3 years. But I do believe, I trust the guys with the booth over there, that in 10 years and probably longer, we still have this PASOE. Maybe it has a different name. Maybe some things changed. Maybe it's no longer based on Tomcat, but I believe that the code that we put on the PASOE now will outlive the next 10 years. And I'm not going to make any predictions over the next 10 years. So front ends is something that I expect to change more frequently than the OpenEdge backend. Which is why we put so much effort in the backend. That sometimes leads to the fact that customers or prospects see us as the backend only front end, because that's what we're really famous for. Build One uses our backend under their front end. Today we've seen a presentation from Organi where they use our backend under the Rapid Cloud Development Framework. So our backend can be used under different front ends, but we do also have our own front ends, and we have customers using them quite successfully. When building business logic, we have relational and object relational constructs. So you can access data returned by business logic objects through temp tables and pro data sets that are the relational constructs, but also through class-based interfaces to classes. And whenever we start talking with customers about modernization, or very often it happens that they hire architects, or architects from different departments become responsible for OpenEdge modernization. So it's not very uncommon that a .NET architect suddenly sits on the table, and if you tell them something of using temp tables to represent data, they look at you, what? We're not using tables, we're objects. So just a style which, besides good technical reasons, is just expected to be seen by people outside of the OpenEdge world. Quite an important aspect for us has become RESTful interfaces, the ability to expose our business entities through RESTful interfaces. That's actually the foundation for client independence. RESTful is a standard that every client developer knows to consume. So we have a lot of effort put into developing that. With different front-end choices. Within the product, we distinguish architectural components, so for the layering of the application, but we provide an application framework which is optional to use, but most of our customers are using it for providing things like authentication, authorization, localization, so translation and other similar features, menus, workflows, scheduler, quite a long list. The framework is designed to integrate with existing OpenEdge applications or frameworks. And we do have some modernization tooling, which I'll be showing you a bit later here. When we provide the framework to our customers, we provide the full source code to our customers. The customers also have the right to make modifications, but since we do very frequent updates to the framework and are very flexible in allowing customizations without changing our code, no customer really does that for long. Sometimes they do that as more the prototyping when they see a need to customize something where we are not yet allowing it, and then they usually get back to us and we'll see how we can get that customization implemented without having to change our code. We do up to weekly releases, sometimes only every 2 or 3 weeks. And we make sure that the framework works with every new version of OpenEdge. And so it happened for the first time since a couple of years, last week, that when we did our testing for 12.8.4, we found out that there was something which is now confirmed as a bug in OpenEdge that caused the framework to misbehave. So we had to provide a workaround for that. Developing the workaround took us like half a day after we installed 12.8.4 on our test server. And so that's something that then is for the benefit of our customers. We usually upgrade to the latest version of OpenEdge faster than they do. And those customers where we know that they were really eager to go to 12.8.4, we knew that, and we could email them, say, hold on for a couple of days, there's something that we need to investigate. And on Monday we could release an upgrade of the framework that works around this issue, and today we got the confirmation from Progress that this is now a high priority bug. So, but they need more time than we to fix this. So yeah, the application framework, I mentioned some of these features before, and let's look at the architecture component. So the backend is, as I mentioned earlier, I believe, the component of the application that lives for the longest time. Front ends will change. And the backend is, if you think of multi-channel applications, so the same application with different front ends, so maybe an in-house web application, a customer web portal, and some B2B integration using web or REST services, then that all should be accessing the same backend business logic through different front ends. And so it's service-oriented, following the principle of the OpenEdge reference architecture. So OpenEdge reference architecture is around since a while, almost 20 years. But those terms like business entities, business tasks, that are central terms in our application architecture too. We provide tooling support for the development of business entities and business tasks and other services. Yeah, relational, object relational. The framework is modular. That's very important during modernization projects, because in a modernization project, there's always an application to be modernized, and maybe there are aspects in the application that are so important to that application that they should remain there, but actually have the same functionality as something we have in the framework. Could be menu authorization. We have customers that say, oh, our menu authorization logic is so specific to our needs, we need to maintain that. Well, then we say, okay, well, then we wrap it into a class that provides the same interface that we need, and through configuration, we can then use that implementation instead of our standard application. And we have hundreds of these framework components that can be replaced or customized in that way. Good. So that's our business end designer. I'm going to use that briefly to build a business entity. The business end designer is an OpenEdge application using GUI 4.net. So most of what you see are the infogistic components that Progress provides. And in the core of it is a design canvas where I can add database tables to it. And because it is an ABL application, it's very easy for an ABL developer to interfere with what's happening when I drag a table from the database schema on the design canvas. So some customers leave out certain tables based on simple ABL code, or rename fields, or do similar stuff, set defaults. It's very often that the legacy database or the legacy applications database has, I don't know, 3 or 4 letter names for all the tables. In MSG Pro, the item master is PTR, MSTR. That's the name that I wouldn't want to use in the future. I would like to use an item master with nice capitalization and stuff like that. So in the same way, we could apply a dictionary of old names for tables and fields to new names, so that we can, in a consistent way, use or build up an application schema that is just easier to consume by new developers. Because a new developer that sees PTR master, that looks like COBOL, and it's not the language, it's the database schema that's giving them that impression. Same also when I drag in a relation here, we need to find out what the fields are that make up this relation. By default, we use the standard rules of progress, so same fields and indexes and so on. But if, for instance, we would be using a build one database, that would also be a self handle to a ref handle. And it's a different rule. It's a rule that we can easily express as ABL code. But we cannot foresee every rule, so that's why it's important that we can customize that. And when we look in the options of the tool, there are many configuration options here. So for instance, for the relations, that's the name of an ABL class that's used to provide the field pairs for the relation while I was dragging around. And if we would have more time, we could look at it, and it's actually very straightforward ABL coding. The main purpose of this thing is I can pick a folder to generate the business entity and related code. And I can click the generate button straight away. Generating the code through a number of extensions to the code generator. And when I'm done with the code generating, it's opening the generated code. So starting from here, so that was generated just now in the development environment of choice. So we equally support Developer Studio or VS Code. And more of our customers like us are moving towards VS Code. Unfortunately, especially in 12.8, Progress Developer Studio isn't performing that nicely anymore. So at 12.5, Developer Studio took a big road downhill. And that's the biggest push for VS Code adoption that I'm seeing. So code was generated, and now I could be looking at the code. I could be adding now custom code to it, so like custom validation. I could also use the properties of fields to add validation rules. So I could be saying name is now a mandatory field. What? We now see this as a validation attached, and when I update the existing code, then we will see that in the existing class of code for a validation rule that it should not be null or empty has been added. As a developer, one of the first things that I would probably be doing is seeing that this component does one of its core tasks, fetching data. And especially in an environment where we have AWL developers doing a backend and maybe front-end technologies and in any other technology doing a front-end, it might be challenging for a backend developer to test that this component delivers data, the right data and the good performance. For instance, when I run a certain query, actually doesn't matter which city I look for, in Boston and run that query, the result came relatively quick. But my sports 2000 database is a gigabyte in size, and I'm cheating. My shared memory is a gigabyte in size, so the whole database is in shared memory. If you look in detail, that query was running 201,000 records. So if Tom Bascom, even on his birthday, would see that I deploy into production queries that to give me a handful of records need 200,000 records, he would end our friendship immediately, probably. I mean, after singing for him, he probably does it anyway. But so this is how I can see that if this is a query that the application would be doing by the city, I know I need an index, I mean, or a different kind of query. But I definitely know I have a problem because in order to return a handful of records or two handful of records, reading 200,000 records in a database, it's just not acceptable. And it's something that's very important to see early. And yeah. So the other thing that I can do now, is that the one that I just generated? Yeah. I can create a simple procedure . Just picking the right one. Why did it? one that I want. So with this code, you can make it a bit bigger. I'm now having everything to access data through the business entity. The business entity should be the one place where all the business rules, like calculated fields that have a different value than something that's directly stored in the database. And when I update records, store that in the database, I can do that through this object. And when I provide a value to the constructor, then it's going to fetch the value based on the prime unique key. If I don't know that, then I can write a query like that. And this is running a dynamic query, but because it's all based on generated OO code, it's actually going to prevent me from making any typos. So I cannot provide a wrong data type here, and the field name is definitely there, and you can run that query and look at the data. And that's one way how we could consume data coming from the business entity within other components of the application. And I could now immediately also use this business entity as a RESTful service. RESTful is a standard protocol for integration between applications. So 15 years ago it was SOAP, maybe 10 years ago it's SOAP, or 5 years ago. Nowadays, when you have to integrate with an application, it's most likely that you'll be using REST. So HTTP with JSON messages instead. HTTP with very strict XML messages. JSON is a little bit more flexible. So we believe that with the SmartComponent Library, we provide the easiest way to build REST services with OpenEdge. And that allows us to expose existing functionality as REST service, but also build new business logic as REST services. And we provide a Swagger integration out of the box. That's a tool for documenting RESTful services, but also allows a developer, either the developer that builds the service, but also a developer that needs to consume the service, to test the service before he basically writes the application that talks to it. The deployment of a RESTful service is very easy. Nothing compared to the hurdles with building Progress REST adapter resources and deploy them and praying that they actually work. We just have a couple of files. Based on that, we built the REST interfaces dynamically at runtime with caching involved to make it faster, and it's not always the same initialization time. And we round that up with authentication features. We support the latest Swagger open API specifications, and yeah, through that we also support an API first design. So if we are in an integration scenario where somebody says, hey, here's the API specification that we need the ERP system to integrate so that a data warehouse or a warehouse management application could be communicating with it, then we can build the service stubs all based on that Swagger file. And if somebody gives us an open API specification, here's the specification of the application you need to talk to, we can create an ABL class that makes it very easy to consume those services. So that's one example for a method. We have our own scheme of annotations. So there, wrong button. So this REST method declares this ABL method to become a RESTful service. We define the ABL class that's used as the parameter, the HTTP method, the relative URL, and what should be returned as the data and parameters or cookie values, etc. And based on that, we do all the parameter handling into this method here. Well, that method doesn't do a lot, but let's use the business entity that we've just built and make that a fully RESTful service. So I go into the business entity and I add a new interface to it and two annotations. Which for Making it faster, I copy from here. And I need to provide a unique URL. So all I do is I save this code. And we now see that in the background, the process is started that extracts that annotation into something that we can consume at runtime. Then I delete a cache file and trim the PASOE. And that's all I need to do to make this REST service available. Now I go into the Swagger page. First time loading the Swagger page now takes a bit because now we're building basically the REST adapter definition. And when that's done, we can look for the book challenge 2 endpoints here. And just by these two annotations, we have the full set of RESTful annotations. We can delete data, create data, fetch data, access records through a primary unique key, update records, either the full record or just individual fields. So if I want to try it out now, I can say I want to make, I'm not going to do put, I'm going to do patch. Patch is the update of individual fields. And I'm going to just change the email address of customer number 1. And run that. It confirms me that it has updated the record. And now if I fetch the whole record number 1, we're seeing that the email address has been updated. Well, we don't know what was there before, but I believe it was updated. So and through the business entity, we've now went to potentially all the validations that we've put in there. That makes it very easy to reuse business logic. And the code that I've done earlier with fetching the business entity through the model class is actually accessing the same component. So, Arisa, we have 2 colleagues from there here in the first row. There, Frank is project manager, no? Called me a couple of months, was in the spring. And we had a very nice project over the winter, early spring, providing backend components for a new customer portal. And normally after such a project, you have to run after the customer, hey, can we do a reference story? And then Christina needs to call them up. And Frank called us, hey, can we publish this to our customer newsletter? And can you provide us a quote? And when I didn't reply within hours, he was calling, hey, Mike, did you see this? We want to post this. And so it's actually quite a nice reference project that was quite fun to do. Yeah, I think went quite well. So, but that was no UIs yet. So we do provide UIs, Windows desktop UIs based on GUI4.net or pure.net. We have web applications based on Angular and CanUI, mobile applications with some prototypes based on Razor and Blazor. That might be a future UI technology for us. The RESTful, which is also a foundation for UIs, and we have partners like Build1 that have built their own applications around our backend. And that allows us for a various choice of migration strategies. On the beginning, it's either ABL GUI or TTY. The customers that we start with are equally spread. Either have a very old TTY application or a GUI application that might be almost as old. And they want to change the UI. And depending on their needs, it's either a desktop application. We still have customers that today start desktop modernization projects. And for some customers, I still believe it's the right technology. Desktop has benefits with integrating with other Windows applications, with other resources on the desktop. It may be a little bit more complicated to deploy it. Desktop applications can be used over the internet, can have the backend in the cloud, all that is possible. It's more deployment effort. I think most of you are using Outlook as an email client, and on every day have the choice to either use the desktop application Outlook or to use Outlook Web Access. And I guess most of you choose the desktop application. So there must be a reason why you do that. Microsoft is probably capable of building very nice web applications. So, but others know they want to go with our Angular client because they need to reach users where the deployment is really a problem, or they're in a marketplace that just wants web. Very often it's a marketing argument. We need to go to the web because everybody goes to the web. There's a certain tendency between in-house applications and applications that are sold to other customers. In-house applications probably more of a tendency for desktop application. It's also a matter of complexity. Web applications always are more complex. You at least add a second programming language. That alone adds complexity. That means you most likely have to deal with two different kinds of developers, ABL backend developers and JavaScript, TypeScript front-end developers. So that there are various reasons. Then we have customers that know they need to go to a custom web front-end. Ariza in the future will go to an React or Vue, whatever web front-end, which they had been using before they started working with us. That's fine. We have customers that we work with because they're using the build one front-end, and we have customers that use us in a fully headless fashion, so where there's never going to be a classical user interface. Oops, twice? No. So for our user interfaces, we prefer to use a repository-based user interface. So we store the UI definitions of which fields are where and with which attributes and some functional arguments, functional parameters like which fields should be enabled during an update and a create or a copy of a record and stuff like that in a repository database. Repository database is an OpenEdge database with a scheme that's just built to store this. It's a way of storing generic objects with attributes and relations between objects and inheritance, and we can use it to store UI designs. Storing it in a database has a lot of benefits. When we believe that UIs will change over time, storing it in source code means you have to convert source code, and converting source code is much more harder than converting data. It's a very simple reason. Well, we're not the first ones to use that. Microsoft, when they introduced WPF, they also introduced an XML-based UI markup. XML is just another form of data, and not source code, not classical source code. So we have runtime components that then understand this data. We have developer tools that create that data in a what you see is what you get fashion. We have structures to allow runtime customization so that in different situations the UI layout would be changing. Maybe for different types of users we would be returning more complex or simple UIs and stuff like that. And with the repository we provide a single UI designer that can be used for multiple UIs. So let's look into that. So the designer can be embedded into an application that could also be used by users. So the separation here between the user runtime and the developer runtime is purely by privileges. So normal user you wouldn't allow to change screen designs. Most of our tooling is still in a desktop application because that's what we've been doing for the most time. And a good portion of that is available already in the browser. We can look at that if you're interested later at our booth. But when I pick an existing form from the repository, then since it's data, we see most aspects here as data. We see there's some instance of other objects like a grid, and the grid as a reusable component. I can edit it here. I could be dragging additional components into that grid, changing properties, either just by changing the width of the fields here and changing the order, or by using the property sheet and changing them. And as we see, we have data being previewed there, so that's really very close to how it would look like in the desktop UI. And if I look at the viewer component, the viewer is like an ABL frame, where we have the individual fields. We see there's a lookup, some simple fields, buttons, etc. And I can simply drag them around and save it. And when I run the screen, I can run it either as a desktop screen, or I can run it in our web application. It's an Angular web application which I'm hosting here in a C# browser. That's a browser that can be very easily integrated into the desktop client, and I can launch the form from here. So now we actually see the same screen being rendered as an Angular web application or a desktop application. And the screens can be more complex. More grids, tab folders, trees, whatever we want. But let's look at what we do with existing screens. So we have various strategies to work with existing applications. First, it's absolutely common that we run the SmartComponent Library application within the runtime of an existing GUI application, and then step-by-step modernize screens. And all the APIs that we provide can be accessed from the existing code, and the SmartComponent Library can access the APIs or the functionality of the existing application really without any limitation. But when we want to migrate tools or migrate applications, we use an ABL or tool to create an abstract syntax tree for an ABL application that allows us to read more or less every ABL source code that compiles. Sometimes with very old applications, we found weird ABL constructs that probably nobody knew that they would be compiling, and then the parser doesn't understand them, and then we have to extend the parser. But generally, this parser understands ABL code very well. It understands it very well without having to execute it. So soon I'll show you that how we deal with UIs and code in the UIs. We're not running the screen and going through the widget tree. We're really interpreting the code. That's quite important, because in order to run screens, you might have to really be in the old application. You have to pass parameters to that. That's very difficult for tooling. Looking at the source code is not easier, but it's just more consistent. And what we always try to understand are certain patterns in the application to help us to distinguish relevant and not relevant code. Not relevant code would be code that just controls standard UI behavior. We don't care about the code that enables or disables the delete button based on whether a record is available, because that's handled by standard components in our new UI. So we have to understand this code as irrelevant code that doesn't get migrated. So we're not intending to migrate every line of code. We need to separate business logic from UI logic, so code that just manipulates fields or enables fields, etc. We need to be prepared to collect business logic from multiple screens and migrate it into a centralized component, because we want to get away from redundancy in the code. We want to get to single responsibility. Every functionality should be implemented in one place. We have cross-platform APIs that make it quite easy to translate ABL GUI behavior, relying on properties like sensitive and screen value into something that could even be running in an Angular web application. There are a couple of frameworks where we've done that before, and the benefit of if somebody's coming from these frameworks like 18.102, we've seen them before. We know what is relevant and the non-relevant code there, so that makes it much easier. The analysis phase in the beginning is much shorter for us. Yeah, but in the end, the foundation is always our abstract syntax tree, and we have code that understands standard things there and deals with that in a certain fashion. Let's look at an example here, an old TTY style or TTY application with an update editing statement. Who did character coding in his earlier life or still doing? You still run into these update editing statements. They are nasty. It's basically a loop which always reads a key that the user presses and then sees if I'm still in the field or am I leaving that field, or am I pressing F2 to save it. So if it's the next field, or go pending. That's usually the code construct that you find to understand validation. So let's look at this screen. So I run our frame migration utility. And I open that program. And the first thing we do is we look for frames in that program. Maybe I should look at the source code first. So that is this program. It's actually a TTY program that I built in the app builder because I was a bit lazy. But this frame statement has been parsed to get the fields on the screen. And now I can use this as a foundation to build a business entity. Because we have fields from 2 tables here. There's a query in the code behind, a lot of building blocks for a business entity. So I'm going to build a new business entity, and I'm using the customer table as the lead table for that business entity. Usually the tool is making a very good guess on that based on which records are accessed first, but sometimes the code is a bit special, and then maybe the developer would have to correct the decision, which is possible. And that's going to be my PUG challenge 3. And it's generating the business entity or generating the business entity design. And we see in the business entity, we do have those fields from the customer, but we also have this rep name, which is from the other table, which was also appearing in the frame. And I can now generate a business entity out of that. So that's just now basically the skeleton of the business entity. We especially see that the validate data method is still empty. And now I can continue in this tool. I can open our abstract syntax tree based tools, and I can search for update editing statements. There are 2 in the code. So it has found that statement. And here we see then one of these typical constructs is actually quite close to something that we had at a customer case. If the old field is name or go pending, it's basically on leave of the name field, or when I'm pressing F2, and then we're validating the name field. And here we do the same for the sales rep field. So that's a code structure that's very common in these TTY applications in one form or the other. So they're always different flavors. And through a single click, we're now migrating that into code that we could use in the business entity for validation. So I'm selecting the business entity that I created a second ago. And what we see here is basically the code to be pasted into the business entity. We're no longer using the input phrase to access the field values that are currently on the screen. We're now looking at what came in through the temp table into the business entity. We have the validation rules translated like that. If there would be name changes between the temp tables and database fields, they would have been applied. And now I'm prompted whether I want to paste this code into the business entity. And if I now look into this business entity, magically we have the code block from the update editing statement there. This is a very simplified sample, but this actually works with way more complex calls. It could also be running internal procedures, which we would find out, and could be turning into methods in the class and stuff like that. And with that, we actually have now the validation code here. And if I paste the same set of annotations into this business entity, where's my notepad? And I use maybe the 5 with the URLs. And then I prepare my PASOE for updating it by deleting the cache file and trimming the PASOE agents and reloading the Swagger page. Then we'll actually see that we turned validation rule from a 30-plus-year-old TTY application into validation rule in a RESTful service. So it's this one. So one of the rules, we should look at the rules there, is just checking if the sales rep is correct. So finding the sales rep based on the input value for the customer's sales rep. And if not there, then we have this message, please enter valid sales rep code. So let's do the patch method here. And I'm going to patch customer number 2. And I'm setting the sales rep to, I don't know, I don't think we have a sales rep with that code. So it's still valid JSON, yeah, and run that. And then we see that along with other information, with getting the error message, please enter valid sales rep code, DDD is not a valid sales rep. So that's re-architected from TTY GUI into a RESTful service. Good, let's look at the next samples. In some cases, not in all, that depends really on the way the modernization goes. The layout of the screens, so which fields are on the screens, etc., can be a good starting point. Some applications say, no, we're changing our workflows and we're going more wizard style and not the big data entry screens anymore, or the other way around. But we do have customers that say, no, more or less the screen should look the same. So the same fields, certainly with some rearranging, some touch on the layout, but as a starting point, the old UI design is quite useful. And then, well, we can pass the code and we can translate the form statements into our UI layout, but we also detect certain UI patterns. And typically, lookup fields or zoom patterns is something that's easy to find. So we find fields that have a button next to them, fields that have an F3 trigger, so on F3, blah, blah, blah. And if in these triggers we find whatever record where key value equals what is on the screen, then it's pretty much certain that that's a lookup screen. and a leaf trigger and all that stuff. So we can understand those. From two fields, maybe those are fields that should also be replaced by a certain component that makes it easier for the user to enter a to from date fields, changing them into a more modern calendar control, etc. That's what we understand under UI patterns. And into this tooling that translates the screen layout, we can add plugins. And plugins are again just ABL classes which are specialized for the use case that we're looking at. So that's now another screen where we now have detected two different frames plus the default frame. If I look at the customer frame, then we see at some fields, so here country, sales rep, we have found that those are candidates for lookups. And we found out that the country lookup that's predefined in our UI repository is probably the best fit based on the table that's being used there. So if we would be looking into the plugin, we would be seeing that we look for certain UI triggers, we look for the find statements, and yeah. And in many applications, the code to detect these that we have there works out of the box. And in other applications, we have to tweak it a little bit because the coding style is different. The better we understand the coding style, the better we can teach the tool how to do this. We're not yet using AI, so we have to write ifs and elses and cases and whatever. The good thing is, if anybody ever worked with AI and code generation, this is really deterministic. You know, it does the same good or bad decisions today that it did yesterday. With AI, it has days where it has a different mind than on other days. But we are thinking about ways how we can involve AI in this, but I'm not expecting that to be ready in the next couple of months. So it might be more something for next year or the year after. But I don't know, AI moves so fast. But today I'm not aware of any tool, any AI where we could drop legacy ABL code in and we either get our abstract model out or refactored code immediately. That I haven't seen yet. And if I look at the migrated result of that screen, did I close the, why did I close it earlier? Then we see a screen that looks pretty close to the ABL GUI screen that was the input. A couple of rectangles that have been recognized as now being real containers for the fields, the shipping address field there. And let's open the input screen and open that in the app builder. Then we see that was the input with the ActiveX control in the way and the actual frames behind it. And the frames have been properly recognized. No, it's not that one. Did I use the wrong one as the input? It's a different one, no? Yeah. But it would be looking just like that. Good. Then let's move to the last topic. Because now we've seen TTY validation code going into a business entity for validation, GUI code or GUI layout being migrated. Another very interesting topic is what do we do with the UI trigger code? And in a bit more abstract fashion, I'll be talking about that topic tomorrow in the afternoon in my presentation. But there are various aspects of what we do with client logic, and different ways how we deal with it. And there are various points that play into that decision. Our preferred way is to move most of the front-end coding into what we refer to as server-side event handlers. So move the whole code block into the backend, return all the data that's on the screen into the trigger, backend trigger, and return a structure back that says what's changing in the UI. So some fields should be colored red, other fields should be disabled based on a change in the UI, etc. Client-side event handlers make it easier, make it more flexible with very specific UI controls. On the server, through our generic approach, we're trying to normalize what we expect to be happening on the screen. Opening queries on the front end that different data is shown in grids or different data is shown somewhere, opening other screens, showing error messages, asking the user questions, enabling, disabling fields, changing colors, all those are things that we can do, probably a few more. But if there would be a custom control and we would have to change something in that custom control, that's not something that we do on the server. That's something that should be done on the front end. And of course, both strategies can be mixed. So we do that for the standard events. That also gives a great chance for reusing the front-end logic in different screens. So if the old trigger was like that, on value changed of the customer number, we find the customer, if it's available, we populate some fields with some values from that record. We display, I mean, this is nonsense here, but we display a value in another field. Another field gets a color of 4, which is red, and becomes insensitive, and the carrier becomes invisible. And the focus goes into that. So these code blocks, they are sometimes very big. And the bigger they become, the more certain it is that it's actually business logic and not front-end logic. And there's data access. Here's just access to a single record, but sometimes there's access to multiple records. And then it's even more certain that we don't want to teach an Angular developer or Vue developer today how to translate that into Vue code, and in 2 years teach another web framework developer how to translate that into another style of TypeScript code. So we have standardized input to that, and that then brings us also into this onion architecture model where we treat those as application services, because they are backend services that are actually very specific to a type of front end, to a kind of application, and they could, depending on how well structured you want to make your architecture, it always has pros and cons, be accessing then domain services to actually get to data. I'm not going to show the demo anymore, but the code. So that's then one of these backend methods. And the code has been automatically generated. So here we have a find into the customer table based now again on a temp table field. If the record is available, we update fields in the temp table with what we found in the database records. We update the instructions field with this nonsense formula. And here we add to a structure instructions what should change on the UI. We are setting the instructions field to sensitive or insensitive. Carrier should be no longer visible. The setting of the color to 4, we're translating that into a named style error, because you couldn't convince me to keep on maintaining color numbers when we're dealing with cascading style sheets on both the desktop frontend and on the browser-based frontend. So we have named styles and error as one, and then the CSS may decide that that is red or whatever. And the focus should go into terms. And so we can translate the ABL statements that did it on the UI into this. But if you look at that, you may say, well, we're not really happy with this. We have a direct database access here, and earlier you told us that the business entity should be the only way that's accessing the database. Well, then we run another conversion that, that was, I don't have that on the slide anymore. Well, we actually have another conversion access that turns this database access into access through a business entity. And really the cool thing now, maybe for, I don't know how much time, we've been asked, how can we test our UI logic? So now this is UI logic executed on the server, but it's a simple method with a well-defined input and output. So I can write a unit test now that reads data that should be coming from the input from an XML file here, makes a change to it, so customer number should be set to 1, and simulates the value changed on the custom when it calls into the handle custom changed, and then I assert on the result. And this way I can now write very simple reusable unit tests, like for any other backend functionality that's executed on Able Unit or our own unit testing tool, whatever you prefer, whenever you change code. And writing UI tests is something that will have to be revisited each time you make certain changes to the UI. And backend tests are really much, much easier. Here's a replace of the direct database access. I had the slides in the other order. So this is then how it would look like with replacing the find statements to database table with our dataset models. Good. With that, I have to come to an end. If anybody has any questions? If you have questions later, you'll find me at our booth. Thanks for your time and enjoy the rest of the conference.